All right, let's try a couple more that have some more complex transformations to them. So this time we have a negative in front, so that tells us we are reflecting over the x-axis. And then we're adding 2 outside of those absolute value bars, so that's a vertical movement. And when it's a vertical movement, we do exactly what it says. So since it's positive, we're moving up. So I'm going to plot the points of our original parent function just so we can see how we're moving. So original parent function is at 0, 0, and then it moves up 1, out 1 each direction. This time, we are going to move our graph up 2, and then it's going to become upside down. We're going to reflect it over that x-axis. So instead of our vertex at 0, 0, we're going to move it up to positive 2, and this time it's going to open downward. But since there was no stretch or compression, stretch or shrink, we know we're still going out 1, down 1, out 1. And this time we're going down instead of up because of that reflection. All right, so for our what kind of line we're going to draw, we do not have an equal to bar, so that tells us we have a dashed line here. So we're just going to kind of play connect the dots there, leave some breaks. And then our last step, we need to shade. So we were given a greater than sign, which means we are shading up the y-axis. So going up the y-axis is right here, and that means we're going to shade everywhere outside of our graph. But let's check ourselves by using a test point. So again, I'm going to keep it simple and use the test point 0, 0. That would be my suggestion to you. As long as 0, 0 is not a point on the actual V of your graph, keep it simple. Make it easy on yourself. So we'll have 0 is greater than the negative absolute value of 0 plus 2. The absolute value of 0 is just 0, and negative 0 isn't really a thing. So 0 plus 2 is just 2. 0 is not greater than 2, so that is a false statement. So that means we should be shading away from 0, 0, which is exactly what we did by shading up the y-axis here and everywhere outside, away from the graph. All right, for our vertex. Vertex is that point in the very center of the graph. So in this case, because we shifted it up 2, that point is at 0, 2. And then this time our graph has a reflection to it. So that means that vertex is sitting at the very top of our V, which means it becomes a maximum. So anytime we've got that reflection over the x-axis, your vertex is going to be a maximum to your graph. All right, let's try one more. This time we've got quite a few transformations happening. So I'm going to list them off to the side. We have a reflection over the x-axis. This time we do have a compression because we have that number in front of the absolute value. That's going to be a shrink, so that's going to affect the slope of our line. So instead of just going up 1, out 1, or down 1, out 1, now we're going to go up 2, out 3, or down 2, out 3. And then inside, we're going to the left 2. And then lastly, outside, whoops, let's change that arrow. We are moving down 1. Okay, so when you have multiple transformations going on here, order is very important, and we follow our PEMDAS steps. So that means we start inside the absolute value bars, we move to what's being multiplied in front, and then lastly, we deal with any movement up or down, what's being added or subtracted at the end. So we're going to start with moving our graph left. then we'll reflect it, then we'll use our slope to find our extra points, and then we'll move them down 1. So that'll be our last step here. There's going to be a lot of movement here. And actually, these two can probably be interchanged a little bit. As long as we get that vertex where we need it to be, then we can use our slope to find some extra points outside. So I'm going to plot the parent function first just so we see our starting place. Okay, so instead of it being at 0, 0, we're going to move it left 2, and we're going to reflect it, and we're going to move it down 1. So our vertex is going to start right there at the point -2, -1. And we know that that graph is going to be opening downward because of the reflection. And now we're going to use that slope 2/3 to find the other points on the sides of our graphs. So we're going to move down 2 and out 3 in each direction to find our new points. So remember, a shrink or a compression makes our graph really wide. So that's why these points are going pretty far out there. Okay, now that we have our points, we can figure out what kind of line we're going to draw. So we do have an equal to bar this time, so that tells us we're going to have a solid line. So we're just going to connect those dots here. No spaces in our line this time. And then lastly, we can shade. So we have a less than symbol. So that tells us we're going to be shading down where the y values are decreasing, which will be moving down the y-axis. So moving down the y-axis is right here, and that sits inside our absolute value graph. So we're going to shade everywhere inside that absolute value v. Let's just double check ourselves, make sure we did that correctly, and find a test point. So again, going to keep it easy, make that test point 0, 0. And we're just going to plug that into our equation. So we'll have 0 is less than or equal to -2/3 times the absolute value of 0 plus 2. Whoops, not a parenthesis. And then subtract 1. So 0 plus 2 is just 2. The absolute value of 2 is also 2, so that means we have -2/3 times 2 minus 1. When we multiply a fraction, we can multiply the numerator and divide by the denominator. So that's going to make this 2 times 2 is 4, and then divide by 3, so that's just -4/3 minus 1. And that's going to simplify to, let's see, that 1 would become 3/3, so we can combine those fractions. So -7/3 is greater than or equal to 0, or 0 is less than or equal to -7/3. 0 is not less than or equal to any negative number. So that means we were supposed to shade away from 0, 0, so not outside where it sits on our graph. So we shaded the correct direction by shading everywhere inside that absolute value graph. And that covers how we graph absolute value inequalities.